Hello, welcome to our tutorial on using our Vernier LabQuest units along with CO2 sensors in order to determine productivity in plants. I wanted to start by showing you the two different kinds of LabQuest units that we have. Using the LabQuest units, it is essential that you have the lanyard attached to the unit either around your neck or attached to your wrist. To begin with, we'll want to turn on our LabQuest unit, and the way to do that is to press the button that is on the top of the LabQuest unit. Okay, it's on. You can see that the LabQuest unit is ready to go, and so we are going to determine productivity in our plants using carbon dioxide sensors, and I have one here. In order to do this, the first thing we have to do is plug our CO2 sensor into the LabQuest unit, and they get plugged into the channel ports that are on the side of the unit. Okay, so the first thing we have to do is calibrate our CO2 sensor to make sure it's reading the correct concentrations of CO2 in the atmosphere. Atmospheric CO2 concentrations are usually in the neighborhood of about 380 to 420 parts per million, and so we'll check to make sure this sensor is reading properly. The first thing we have to do is make sure it's on the correct setting, and you'll notice on the side of the sensor there's a little toggle switch. We want to make sure that the sensor is on the low setting, which is 0 to 10,000 parts per million. You'll notice that initially the sensor reads about 19 to 25 parts per million, which is pretty low, but it usually takes about a minute for the sensor to begin picking up the CO2 concentrations in the bottle. So it's generally a good idea to wait about 1 minute before you determine whether the sensor needs recalibration. Okay, so you'll notice that the sensor is now reading about 440 or so parts per million, which is pretty close to normal atmospheric CO2 concentrations. And it took about a minute to get there, and so be patient before you decide whether the sensor needs calibration or not. If the sensor does need to be recalibrated, that is, it's reading outside of the range of about 300 to 500 parts per million, then to calibrate your sensor, you'll notice that on the side of the sensor there's a small recessed button labeled CAL, and we'll need to push that button in order to recalibrate the sensor. And the tool to do that with is your stylus that comes with your LabQuest unit. And you'll simply hold that button in until the light on the side of the sensor begins to blink. And it should blink 3 times. Okay, and there it goes. And doing that tells the CO2 sensor that the concentration of CO2 that's inside that bottle right now is normal atmospheric CO2 levels. And so you'll notice that LabQuest unit is now reading about 395 parts per million. And now the sensor is ready to collect data. I've collected a bit of leaves from a plant nearby here, and what I'm going to do is place those leaves inside our biochamber. And the best way to do this is to place the leaves in upside down, and so you'll want to push them in, and the reason for that is because that allows for the tops of the leaves to be maximally exposed to the light conditions that this plant is experiencing. Once you've done that, go ahead and place the CO2 sensor back in the bottle. Okay, so I've got my leaves inside my bottle, and first thing I'm going to do is I'm going to go up on the LabQuest unit to the File button, and then choose New, and it will ask me if I want to keep that last data set, and I'm just going to say no, discard. Alright, and now I am ready to collect my data. And so you will want to collect data in the place where you actually collected your leaves. So go ahead and place your bottle down where you collected your leaves so that it is receiving the exact same amount of sunlight that it's receiving in its normal growing conditions. So we'll go ahead and hit the collect button and begin collecting data. You'll notice that the graph that appears measures CO2 concentrations in parts per million on the y-axis and time on the x-axis. The default setting for the LabQuest unit is time in seconds, and it's set to automatically collect data for 600 seconds or 10 minutes. Okay, so you'll notice that while we're collecting data here, the scale of the y-axis is quite large. In fact, it's so large that we really can't see much change in the concentration of CO2 in the bottle. So to fix that and adjust that y-axis scale, we can auto-scale this data, and that is in the graph function on the LabQuest unit, and then choose auto-scale once. And now that sets the y-axis to the minimum and maximum values for our data. And the LabQuest unit will continue to auto-scale throughout the full 600 seconds of data collection. We have finished collecting our data, and so what we have to do now is determine the rate of change in the concentration of CO2 in the bottle. However, you'll notice when you look at this data that the CO2 concentration in the bottle stayed fairly constant for a few seconds at the beginning, and then it began to decrease dramatically at a fairly constant rate. And so we're going to want to determine the rate of change for just that portion of the data where the slope of the line is fairly constant. And that looks like from about this point over. Okay? And so what we'll do is just first select that portion of the data by placing our stylus on the screen and dragging over to the end. And then we'll go to the Analyze feature. We'll choose Curve Fit and then CO2. And then we have to choose the kind of fit. And we choose the drop-down arrow here. We're going to fit a linear line to this data. And you'll notice that the LabQuest unit fits that line to just that portion of the data that we selected, and provides us with the equation for that line, y equals mx plus b, where m is the slope, and the slope is a negative 0.45715 parts per million per second. Okay, so just some reminders about using this vernier equipment. First, it's very expensive. Important that you take care of it and follow proper instructions. First thing that you want to make sure of when you're using the sensor is to be very careful about the clips on the CO2 sensors. These small clips can break off very easily, so be very careful in handling them so that those clips don't catch on something and break off. Next, you additionally want to make sure that when you're handling the sensor that you're holding it by the sensor body. When removing the sensor from the biochamber, you want to pull by the body of the sensor, not by the cord. If you pull by the cord, you can break the connection here and the sensor will not work. Okay? You should also carry the CO2 sensor around by the sensor body, not dangling from the cord. And then finally, when you're done collecting data, you'll want to shut down the LabQuest 2 unit, and the way to do that is to hold the on-off switch down until the shutdown screen appears, and then let it go, and then the unit will shut down on its own.